Another topic that we're discussing in this section is something called factors. So the factors of a number, these are the numbers that divide evenly. That divide evenly. All right, so 14. If I was to take 14 divided by, well, I'll do the easy one first. 14 divided by 1 works out perfectly fine. That's 14. So 1 is a factor of 14. 14 divided by 2 works out. That's 7. So 2 is a factor of 14. Conversely, this actually also means that 7 is a factor of 14, and this is one of the tricks if you're trying to find factors. Each time you're able to do this, it actually gives you 2 factors. 1 and 14 are both factors. 2 and 7 are both factors. So let me just write these out. 1, 14, 2, 7. All right. If I was to try 14 divided by 3, well, this one doesn't come out nicely. Let's do 14 divided by 3. You can see it comes out with, it doesn't divide evenly. So therefore, 3 is not a factor. If I was to do 14 divided by 4, again, it doesn't come out evenly. Divided by 5, divided by 6, that doesn't come out evenly. And I'm up to 14 divided by 7. I could go on checking. I could try, what about 8, 9, 10, 11, 12, 13. Numbers that are bigger than 14 certainly aren't going to divide evenly into 14. But it turns out, actually, once I've gotten into, I'll do divided by 4, divided by 5, divided by 6. None of those work. Then I'm up to 14 divided by 7. Now let's figure out why I'm taking note of that one. 14 divided by 7 has actually already been encountered. I said that 7 was a factor up here. And it turns out once we've reached this point, once we've gotten once we're starting to get duplicates, then we're done. Nothing bigger than 7 is going to be a factor that hasn't already been accounted for. If you're going up in a nice, even fashion like this. So our complete list of factors of 14 would be 1, 2, 7, and 14, if you wanted to write those in ascending order. So let's do the same thing for 54. You can see 54 is going to be a lot longer list if we were to go through all of this. Let's see, 54 divided by 1 clearly works. That's equal to 54. So we get 1 and 54. I'll write it out like this, so that I don't have to rewrite these things to get them in order. 54 divided by 2 is, well, let's see, that's 27, it looks like. So 2 and 27 are factors also. 54 divided by 3, let's pull out the calculator here. 54 divided by 3 is 18. Hey, that one works too, equals 18. So that means both 3 and 18 are factors. All right, 54 divided by 4. 54 divided by 4. Hey, that one doesn't come out. Okay. 54 divided by 5. Doesn't work. 54 divided by 6. Yeah, that one does. 54 divided by 6 equals 9. So I'll write 6 and 9. 54 divided by 7. Nope. 54 divided by 8. Nope. 54 divided by 9. That one comes out, but actually I've already covered this one. Which means this is my complete list. 1, 2, 3, 6, 9, 18, 27, and 54. That's a complete list of all the factors of 54. So, what's an easy way to tell if something is divisible by 2? These are sometimes called divisibility rules. Well, divisibility by 2, that one's actually really easy. A lot of people know this one already. It ends in a, what is it? 2, 4, 6, 8, or 0. Don't forget the 0. If the number ends in one of those digits, then it is, we sometimes call these even numbers. Equivalently, we can say they're divisible by 2. So if I had, I don't know, 52, it ends in a 2, therefore I can divide it by 2. This would be 26. If I had 1, 0, 1, 1, 3, 5, 8, I don't really care what else is going on in this number. The fact that it ends in an 8, this comes out nicely. Whatever. I'm not going to bother figuring out what that is. This is just some number. So, we can tell if it's divisible by 2 just by looking to see if it's an even number and if it ends in one of those 5 digits. All right, what's an easy way to tell if something is divisible by 3? This one's a little bit harder. Not that hard, but we sum the digits. And test if divisible by 3. This might seem a little circular here. I'm testing to see if it's divisible by 3 by testing to see if it's divisible by 3. For small numbers, this doesn't help us at all. 9, yeah, okay, that's divisible by 3. This is kind of making the assumption you know that you can do these small ones. 9 is divisible by 3. Where this really comes in handy is when we have large numbers. 123. Not that large of a number, but let's try it out. To figure out if 123 is divisible by 3, what I'm going to do is I'm going to take 1 plus 2 plus 3. This gives me 6. 6 is divisible by 3. So that means 123 is divisible. The reason this one works is really has to do with the fact that we have a base 10 system. If you start talking about other systems of numbers, the Babylonians had a base 12 system, or base 60, I guess, depending on who you ask. You wouldn't be able to do this same sort of trick with that system of numbers. But let's just verify really quickly. 123 divided by 3, it does come out evenly. It's 41. All right, so that's the divisibility by 3 test. Divisibility by 5 test is another really easy one. If it ends in 5 or, not 5 of, 5 or 0. So 1, 2, 3, 4, 5, 6, 5. This ends in a 5, so it is divisible by 5. Those are all the divisibility tests that I think are worth your time knowing. Anything other than that, if you're testing to see if something is divisible by 7, just try plugging it into the calculator and seeing if it comes out. There do exist tests out there where you can check, but I don't think they're worth your time. They take longer to do than just plugging it into the calculator.